Welcome to May 31st LeetCode Challenge. Check if a string contains all binary code of size k. Given binary string s and integer k, return true if every binary code of length k is a substring of s, otherwise return false. So for this, we have this string s, which is a binary string, and we give it an integer k. We want to know if the binary code of length k is a substring of s. So the binary code for the length of 2 is either 0, 0, 1, 1, 0, and 1, 1. Can we find all the binary representation of the substring where k is equal to 2, so length size 2? So can we find all these binary size 2 numbers inside the string? And the answer is yes, because we can find them as such, right? You have 0, 0, we have 1, 0, 1, 1, 1, and 1, 0. So they're overlapping, and that's fine because it's a substring. We're given the string a binary string here. Can we find k length of one binary representation? The answer, the only thing we're looking for is basically 0 and a 1. It's clear that they both exist in the string. However, given this example here, similar as above, we have k equal to 2. However, the binary string, we cannot make the binary code 00 from the substring as a substring from the string s, as it does not exist in an array. So therefore, return false. So we need to be able to return a boolean and find a substring if k exists or not. So the constraints k at the length of s is between 1 to 10 to the 5 times 5. Each index of I of s, the string I should say, is either a 0 or a 1, and the size of k is between 1 to 20. So let's see, we can solve this using a set. Right? So we just made, so the idea is basically, let's recall this idea. Return true if every binary code of length k is a substring of s, otherwise return false. So if we know that to be the case, we can use a set, or the Python built-in set actually. We just need to check every substring with k length, with length k, until we get an absolute, until we get the possible binary code. Since there's two possible characters for each place, either a 0 or 1 in each position, we need to make sure that we have 2 to the k possible binary code. So we can continue until we have up to k 2 to the k what's called count, and then we return false if we did not get 2 to the k counts after the iteration. Otherwise, we need to prevent repeating counting. We could just use a set to store the results until we have previously counted. So so basically 2 to the k, if we use the bit 1 bit shift to the left k, it would be the same thing. So let's kind of go there. So say that we need the, so this so it'll be 1 bit shift left k, and this is basically 2 to the power of k. It's very similar. And let's say we have a set called visited. So this is basically storing all the visited binary representation of 2 to the k substrings. So we have to iterate through for each index I in the range of k to the length of s minus 1, or plus 1 I should say. We are going to develop a temp variable to take the slice between where we are at k at I minus 1k minus k index to I, right, which is the length of size k. So we're taking slices of k amount in each of the string of s, so substrings of s, and we want to assign that to temp. If temp is not in our visited set, which is good, that means we need to be able to add it. So we would visited.add and add the temporary variable, and then we would decrement our needed or required substring our need to be decremented by 1. So therefore, we know that we could basically keep on looping through k elements going downwards. So now that we know this part, if we keep on iterating through this, if need is equal to 0, that means after all the iteration done through the for loop, through the if statement to add it into our visited, return true when all the occurrences have occurred. Yeah, return true. And otherwise, if everything else fails, we will always exit the loop and therefore return false. Run this code. Return false. Code. Oh, visited. Let's submit this. So there you go. The time complexity for this is big O n times k, where we iterate through basically the length of the string s, and we use big O of k to calculate the hash of each set. And space complexity is the same thing, big O of n times k, because we have to set memory usage as well. We actually shorten this a bit more to 1 line, but it's yeah, sure. We could actually convert all this to 1 line pretty easily. We just do something like return the set of s, where we take the slice between 1 minus k to I. Not 1. Yeah, like that. For I in range of k to the length of s minus plus 1, I should say. Plus 1. And we could return actually we could return if this is equal, yeah, that's good, equal to 2 start k, and the length of this should also work. Set. There you go. Run this. There you go. That also works. It's actually almost the same. Alright, there you go. Have a great day, guys.